network security, overview of basic network security concepts. In this video I want to go through a basic router configuration to make sure that we're on the same page. I know this is CCNA security and you should be okay with things like IP addresses, access lists, NAT. Still, I want to make sure that we're okay and we can move on with some more advanced topics. To make it more interesting, I am going to add a firewall on this router. If you've watched any of my CCNA Real World Labs videos, you will know an 800 series router very well. Of course, if you haven't, go and get it. 800 series router, a really nice router that you can buy from Cisco. 870 is end of life. You can still buy 880 series router, ADSL, VDSL, broadband connection. A very nice box. The idea for this lab is to browse the internet using this router. As you can see, F0 is connected to my existing router, and this is like your ISP, and laptop is connected to port F3. We will start from scratch. There is absolutely no configuration on this router. We'll have to assign IP addresses, enable telnets, SSH, and because this is network security training, we are going to add a zone-based firewall. That's my management laptop, and this is the laptop that we're going to use to connect to that router. I am using RDP at the moment with wireless. That's why I can connect to it even though there is no configuration on this device whatsoever. Of course the answer is no, go away. Ooh, that's slow. Come on. Wake up. Here we go. Okay. We'll start with IP addresses. As you can see in the topology, well, must have missed that. This one will be, let me just change, 10.7.7.1. This one is, I think there is a static IP address .2. And this one is DHCP. Our ISP is 172.16.1.252. That's our default gateway. Okay? Right. Let's start with the one, make sure that we can access the internet. I always recommend starting with the outside interface. Make sure that you can access the internet, because if you cannot, then maybe you have to escalate that to your ISP. Host name, let's just call it router1. If you have never set up a router like that before, you can miss that this is a switch. It means we cannot assign an IP address under F0. We'll use, let me just put this information here, we'll use VLAN 2. And this one we'll just keep in VLAN 1 to keep it to make it simple. Okay, this is VLAN 1. Okay? Let's start with VLAN 2. IP address DHCP. We want to get it from a DHCP server. And interface 0 will be in VLAN 2. switch port access VLAN 2. Let's put some description to make sure we can identify it. Okay. Show interface description. We can see our F0 and VLAN 2. Why is it up and down? There is a cable connected to it. Why is it up and down? What's wrong with it? Here we go. You have to be patient. Yeah, there is nothing wrong with it. You just have to be patient. Let's fix the console. As you can see, this message saying that we received, in a way, a public IP address. Is it enough to ping the internet? Well, you all go, well, what about your default gateway? Well, take a look. There is a default gateway. It was learned from the DHCP server as well. That should be enough to ping the internet. Okay. Let's repeat that. This is CCNA security, so I'm going to show you the first CCNA security topic, which is a denial of service attack. A denial of service attack is my firewall, which is over here, doesn't like a lot of ICMP messages. And at the moment, my firewall decided to block this IP address because it has received too many ICMP messages. If we are patient and we wait X number of seconds, I don't remember what's the timer on it, we should be able to ping again. Well, that's too early. Okay, let's leave it. Let's do the LAN side now. Interface VLAN 1, 10.7. I like this IP address. Don't ask me why, it's just I like it. No shots. Description LAN. Interface range F1. I think it's space required here. Description LAN. When I type show VLAN switch, you will see that all ports, of course, are in VLAN 1. We're okay with that. Show interface description. You will see port F3 is up, that's the laptop, and F0 is the ISP. Is it enough to ping the internet from this laptop? I'm pretty sure you know this command that I can use source. Let's make sure we can ping it. I'll take a look. Now it's okay. What I can do source VLAN 1. Is it going to work? The answer is of course not. NAT is missing. 10.7.7.0 is a network that this router has no idea about. My router, or my firewall to be more specific, is saying, well, mate, I have no idea what 10.7.7.2 is. I'm not going to allow you to connect to me. And to be more specific, it is going to recognize that as, well, I'll show you that. Let me connect to the firewall. Just give me a moment. I have to log in. And in the logs, I think it's firewall. Yes, it is. This is recognized as an IP spoofing message. Why? Well, this firewall has no interface related to 10772 and there is no root for it. 10772 has tried to go to these IP addresses and it was denied. Why? Because there is IP spoofing enabled on this firewall. It is here. Enable spoof prevention. Yeah? It is enabled on LAN, DMZ, guest, all interfaces. What we were trying to say is, well, you should not pretend you're somebody else. I don't know what 10.7.7.2 is. I don't know how to route it back. It doesn't make any sense to allow you to go through. Yeah, let me show you that again, just to make sure that you can see that. Okay, there we go. Okay, now it's better. Yes, source 10772 and destination IP addresses. As you can see, that's the ping, and everything has been denied in the last 5 minutes because we have to enable NATs. Okay, let's do it then. 3 steps. Label your interfaces, access list, and the NAT statement. VLAN 2 is outside. VLAN 1, come on. Okay. Interface VLAN 1 is inside. Access list. What kind of access list do we need? You all go, well, it's a standard access list, right? That's what we learn at CCNA. That's a standard access list because we need source. And the answer is no. In the real world, you will never, ever, ever, ever see a standard access list in NAT. The reason for that is we need some flexibility, especially with VPNs. You will see an extended access list or even a route map. Okay, extended, let's call it NAT. Permit IP going from 7. Where? Anywhere. The last thing is NAT statement. IP NAT inside source list NAT interface VLAN 2 overload. Right? Easy. We should see some NAT translation straight away because this PC wants to browse the internet every single minute. That's HTTPS, HTTP, as you can see. It is working. Of course, that's DNS. Let's try and ping it just in case. Source VLAN 1, it has to work, right? We have our basic router configuration. It is connected to the internet. We have NAT enabled. Let's go for Telnet and SSH quickly. Not live, but line. Let's use local database for now. Later on we will use some more advanced solutions like radius, TACACS and so on. Login local will allow Telnet and SSH. For SSH we'll do domain name test.local, generate the keys. Okay. That should do the trick. To verify, show IP SSH. Okay. Let's test it. SSH 10771. Okay. No, I have to create a local account, right? Username admin, privilege, username admin. Let's do secret, yeah, it's CCNA security, right? Let's make it more secure. Okay. Admin Cisco. Okay, I'm connected. Make sure you test it. Do not assume, oh yeah, that's fine, I can connect. No, test it. Of course, it makes sense to create enable secret as well. Okay, basic router configuration. I hope that is very simple and you all go, oh come on mate, that's a waste of time, I want to learn CCNA security. Well, it's always good to go through a lab like that, make sure that we're okay with that. And we have introduced a few new topics in the last 15 minutes. We talked about denial of service attacks, ICMP. Wasn't that bad. Firewall. I will set up the zone-based firewall here. Let's do it then. To remind you, there are 3 main steps to make it happen. We have to create our zones and zone pairs. Step number 2, we need to identify our traffic, class maps, and then we have to create a policy and apply it. Let's start with zones. Here it's pretty simple because we need 2 zones. I will call it zone inside and outside. We need a zone pair, or maybe first let's go under interfaces and under an interface interface F2 and say it is outside. I really wish Cisco gave this option in many different places, like access lists and, well, VPNs and so on, that it can recognize what zones are created, what access lists are available. It's so great. Zone member, security, inside. It's very similar to NAT. We have to identify which one is inside, which one is outside. Okay, that's pretty simple. Now we have to create zone pairs and apply security policies, or a security policy in this case, because we'll have only one. Let's start with zone pairs. We'll have one zone pair. Zone pair security, and here we'll call it, most people do it that way to identify the direction, even though you have to specify it here anyway. Source inside, destination outside. That's the only one we need. If there is no zone pair, by default all traffic will be dropped. That's why we do not need outside to inside for now. In the real world it makes sense to create that, because you might need that one day and it is in place. This is a simple lab, we'll keep it simple. That was step number 2. Step number 2, we have to identify our traffic. What is allowed, what should be inspected by our firewall. We will do inspect match any. Let's call it all, because I want to keep it really simple. To do that, I will match protocol UDP, I will match TCP, and ICMP. Yeah, I want to match everything. Okay, that's really simple. That's what you want to do. You want to match UDP, TCP, ICMP to make it really simple. Okay. Now let's create our policy map. Policy map. Type inspect. Now name, let's call it policy. Here for class, and that's what I meant, there should be a list of my classes that are available, because this is simple. I remember class all. Still, what we want to do, there are three options available, main three options: inspect, pass, and drop. Of course, we can police, apply service policy, but in this case, for a firewall, in both cases, drop, inspect, or pass. Of course, we want to inspect our traffic. If we, okay, let's apply it first. We will go under our zone pair. That was the one. And here we'll type service policy, type inspect, and then our service policy. Okay. Show zone per security, zone inside to outside, and we have our service policy in place. If you want to see if it's working at the moment, there are many commands you can type. You can type show policy map, type inspect, and then you have a lot of options here. Zone pair is an option, and it's going to show you the number of inspected packets. We can see some UDP, TCP, there is no ICMP. We can fix that. Let's try and ping something. It is a good idea to make sure we go through this router, because there is wireless, remember? Yep, that's fine. So let's go back. Do it again. We should see some ICMP packets. There is one more command that is really nice, which is show, what was the command? Policy firewall sessions, I think. Yes, that's the one. It will show you all sessions. That's really handy. Let me show you that. Let me telnet to 10.10.10.1. That's my ASA. And we should see that on the list. 23, telnet. If you want to double check that your firewall is working, when I do show run, you will see this class map over here. What you can do, we can do no, and let's remove ICMP. Okay, let's paste it. Now, go away. We cannot ping anymore. The internet access is okay. I think that's everything I wanted to cover. In this video we talked about network security, overview of basic network security concepts. I showed you how to connect a router to the internet and enable a zone-based firewall. Thank you very much.